Hello and welcome to today's web seminar entitled Real-Time Big Data Analytics in the IBM SoftLayer Cloud with VoltDB. My name is John Hugg and I will be the moderator and co-presenter for today's event. Before we begin, I would like to review a few housekeeping items regarding today's presentation. This is a live presentation through On24 and there are a large number of people on today's call, so you may experience a slight delay when we click between slides. We will have an archived version of this presentation available in a few days, and we'll send all registrants an email with a link to the replay. All phone lines will be muted during today's event to cut down on background noise, but we do welcome your questions. In order to submit a question, please type it into the chat tab. We will attempt to answer as many questions as possible during our formal question and answer session. If you want to join the conversation via Twitter, click the Twitter icon at the bottom of your screen or use the hashtag #VoltDBOnIBM, all one word. Also, you'll see on the right side of your screen we have a resources window where you can download VoltDB, review some of our white papers, review the IBM white paper, and check out our sample apps. Now I'd like to take a minute to introduce today's presenters. First, from IBM, we have Peter Raj, PhD. He's an infrastructure architect and specialist. Peter has been working as an infrastructure architect in the IBM Global Cloud Center of Excellence in Bangalore. He is experienced in the digital technologies including cloud computing, big and fast data analytics, and the Internet of Things, service-oriented architecture, enterprise architecture, the Docker platform, etc. Peter has published research papers in peer-reviewed journals including IEEE, ACM, Springer Verlag, InderScience, etc. Also joining us is Skylab Vanga, infrastructure architect and specialist at IBM. Skylab has worked for IBM for 7 years in various capacities. Currently, he is an infrastructure specialist in the IBM Global Cloud Center of Excellence in Bangalore. Skylab deploys cloud-managed services offerings and is developing big and fast data analytics proof of concepts on SoftLayer cloud environments. And of course, myself, I'm John Hugg. I'm a founding engineer here at VoltDB. I've spent my career working at several database startups, including Vertica Systems and now VoltDB. As the founding engineer here at Volt, I work with Mike Stonebreaker and a team of academics at MIT, Yale, and Brown to build HStore, VoltDB's research prototype. Then I helped build the world-class engineering team at VoltDB to continue development of our open source and commercial products. Okay, moving on. I'd like to introduce the VoltDB architecture for fast data. So VoltDB is really differentiates itself in several key ways. One of the ways that Volt differentiates itself is in extreme performance. And when we talk about performance, we mean per machine performance, which we focused on very intensely when we started this project, and also shared nothing scale out performance. So unique in that it focuses on both of those very highly. How fast are we talking about? Millions of SQL statements per machine, up to 500,000 ACID transactional write procedure calls per second, each of which can contain many SQL statements. And that scales out as you add machines to your cluster. VoltDB includes full disk durability and synchronous cluster replication for high availability. We have powerful tools for streaming analytics. This is something that separates us from many operational stores, including continuous queries, correlation, windowing, aggregation, and more. We also have deep integration with many external other tools that are popular, including deep integration with the Hadoop ecosystem. So that's sort of the broad overview of why Volt is really different than everything else. Looking at the next slide here, Volt is in this confluence between streaming analytics and operational stores. And strong transactional stores. And we'll sort of get to why this is a generational leap over other platforms for doing either operations or streaming analytics. So next slide, please. So in the first generation streaming analytics systems, these are all systems that focus on streaming analytics, including Spark Streaming, Storm, Kinesis, complex event processors like Streambase, Esper, etc. Technically, these systems all lack integrated state for transaction processing for operations, just for lookups to make the stream processing richer. Generally, they have a very narrow focus on what is going by. They all have a non-standard programming model that looks different than your other data stores. They also have no ability within themselves to directly query the data that is being stream processed. So in terms of the functionality, that means you've got streaming analytics on windows of events, but you can't combine that with state without adding a separate database system to include lookup tables, to include operations, to include storage with that system. It requires an additional functionality. It also requires additional functionality if you want to do queries, if you want to hook up business intelligence tools, if you want to take action in response to streaming analytics. You need to take the result of the streaming analytics and feed it into a different system in order to take action, in order to support your operations. So this loose integration between the streaming analytics and the operational side doesn't support applications that require interaction in very immediate response to the streaming analytics. So how VoltDB views the differences here. VoltDB, when we started out, we had a big focus on operations. And what we saw as we started supporting these very, very high throughput, high volume operational workloads is that the users operating these workloads want to understand how their data is changing. It's not enough to mutate data very, very quickly. They need to understand how is the data mutating, what is the big picture. On the flip side, stream processing work needs state in order to enable richer analytics. It's not enough to just focus on that window. You have to be able to focus on that window and broader context, whether that's lookup tables, whether that's deeper history than just a few seconds. Integrating state with your streaming analytics makes that much more powerful. And so we think that operations and stream processing are set to converge. And certainly Volt isn't alone in this opinion. This is sort of, I think, a broader theme in the industry. But you know, we have our own unique solution that we think is spectacular and really tackles this problem in the appropriate way. But so certainly convergence is necessary for the things I talked about in terms of understanding your data is changing, in terms of including larger state for streaming analytics. But crucially, this convergence of streaming analytics and operations allows you to build applications that react faster to data, that integrate understanding with decision making. So within the actual stream processing, you can update the transactional state, the system of record. As you're doing transactions that make decisions on the system of record, you can do the continuous querying, the window querying, the aggregation. You can take the statistics, all of the metrics that you've got in the stream processing, and use that to inform your transactional decisions. And all this, what this gets us is that from stream processing being a passive system that requires additional systems to be active, fast data is an interactive process. And VoltDB is uniquely positioned to enable that for you in the easiest possible way with the least amount of performance challenges. So the next slide, moving on, is our slide's coming. Hold on. The next slide is our view of sort of where VoltDB fits. And as I said before, VoltDB integrates deeply with lots of other systems. We view, Volt is one system among many that our users are running. So looking at Volt as a stream processing, as an operational system, as an ingestion engine, often Volt is directly connected to customers, whether that's through micro-personalization, whether that's through improving the customer experience. VoltDB could also be connected to operations-facing, whether that's network optimization, API monitoring, sensors, whether that's telecommunications, finance, many verticals directly connect to VoltDB. VoltDB is the ingestion engine, the transaction engine, the understanding engine of the fast data. But that fast data isn't the only thing. I mean, big data is still a big thing around here. So VoltDB integrates with lots of ways to get that batch, that non-interactive, that interactive analysis, or the longer-running traditional OLAP queries. So through VoltDB export, we can push results, enriched queries, enriched data, filtered data, aggregated data, or raw data into systems, traditional OLAP systems like Teradata or Netezza, or more modern Hadoop ecosystem tools like Impala, like Spark. So that kind of system, we can use the batch, the deep analysis, for machine learning, for statistical correlations, for deep analysis, predictive analysis, and we can often build models in the deep system that are loaded into Volt to apply to the fast system. So many customers doing this kind of a very together kind of system where they use the big and the fast together to leverage both and to make both more effective. Okay, so that's my brief introduction to VoltDB. Again, if you want to learn more, we've got some resources on the On24 site, and you can come to our website, voltdb.com, at any time. And keep any questions. We'll be answering those at the end of the talk. I'm going to turn it over to Peter here from IBM, and he's going to take you through real-time analytics on the SoftLayer cloud with VoltDB. Thank you, Peter.
Yeah. So this is Peter from IBM along with Skylab. He is my colleague. We are working in IBM Global Cloud Center of Excellence, and agenda or that mandate that was given to both of us is to come out with some sort of POCs, pilots, in order to gain some deeper understanding on how analytics work on cloud environment. So that is the base thing from which we have explored several things, and one of them is VoltDB running on IBM SoftLayer cloud in order to understand how it performs in a faraway cloud environment. And we wanted to know the concerns, challenges, and other risk factors when we move analytical platforms to public cloud environment. So that is the mandate that was given to us, and we have worked a bit on that, and we have gained a lot of knowledge and experience on that. So today we are going to explain how VoltDB is giving the required performance when it is running on a public cloud environment like IBM SoftLayer cloud. So let me put some contextual information here. We all know about the progression or the explosion of data this point of time, because there are lot of new technologies that are coming up, and especially connectivity technologies, service enablement technologies that are enabling all kinds of common, cheap, and casual things to be smart objects. So that is one thing. The number of data sources is going up steadily, and the amount of data that are getting generated, captured, and subjected to variety of investigations is also gaining a lot of attention and drawing a lot of attraction from different quarters in the world. So here, as I told you, two things. Digitization technologies have led to a variety of things getting digitized, especially with the edge technologies. Every ordinary thing is all set to become extraordinary thing. That is one thing. Then the amount of data that is getting generated is also going up. We need to leverage those data in order to extract actionable insights. So that is why data analytics is very, very hot these days, because every company and corporate that is running based on insights-driven knowledge or decisions, then the company is going to attain the desired success in its journey. So here, go to the next one. Okay. So somebody wrote somewhere something like that. By 2020, we will have trillions of digitized objects or smart objects through the maturity and stability of edge technologies, digitization technologies. And we are nowadays seeing a lot of deeper connectivity between various kinds of devices, electronics, physical systems, mechanical systems, electrical systems. So it is projected that by 2020 there will be billions of connected devices. When devices are getting connected, it is natural that we will be bombarded with a variety of large amount of data. We cannot be casual on this data. We have to be very careful in capturing those data, and through technologies, dynamically we need to extract as much as possible from the data. That is the next agenda for us. And the third one is there will be millions of software applications that are going to be very much contributive for the vision of smarter planet. People are thinking about and talking about smarter environments like smarter homes, smarter hospitals, smarter hotels, smarter offices, smarter manufacturing. Everything is getting smarter nowadays. and that is because the data that we are collecting are not kept idle. Instead, they are being subjected to a variety of analytics through platforms, tools, and engines. So other thing is there are different kinds of data that are coming up. People are categorizing like this. Big data, that may be based on the volumes of the data. There are fast data that is based on the velocity with which the data is getting generated, transmitted, and subjected to analytics, processing, and mining, and other things. So there are big data, fast data now, streaming data also. We are hearing very much nowadays, and with the maturity of IoT technologies, now the IoT data is becoming very large in size. So the data size, the data speed, the data structure, the data scope, and all these things are creating a lot of challenges for the IT environments, for the IT infrastructure, IT platforms, because these IT infrastructures and platforms are having a very, very vital role to play in extracting insights and intelligence and knowledge out of those data that are getting originated from different and distributed sources. So here, two things: we need to do analytics appropriately in order to extract the insights. Second thing, we need to come out with applications that are insights driven. That means we need to come out with smarter and sophisticated, adaptive applications that will run the future environment in our midst. So, okay. So I don't want to go too much into data analytics. As we all know, analytics helps a lot of things in automating, accelerating, and augmenting IT systems, business applications. So that are well-known things. So what is the next one? Okay. So now, as I told you, we have big data, fast data, streaming data, IoT data. Then there are several kinds of processing. That means batch processing is there, interactive processing, iterative processing. These are all some of the processing that can be accomplished on different kinds of data that are getting generated. So Hadoop has brought in a variety of innovations in the sense big data are getting captured and they are analyzed very cheaply. Possible through these Hadoop implementations like Cloudera, Catanos, and other things. So nowadays, real-time processing getting a lot of attraction. People are not willing to wait for a long time to get that insights. People want the insights immediately. Whenever there is a data coming in, immediately it is getting processed and insights is extracted and given to the decision makers and other people who are directly or indirectly associated with running enterprises and running the operations. So real-time analytics is gaining a lot of interest these days. Then streaming analytics is another interesting concept, gaining a lot of importance these days. Then IoT analytics. So that is also gaining a lot of things. The most recent one is we would have heard a lot about batch processing on big data and real-time processing on real-time data or streaming data. Now there is a new requirement that is coming up is the real-time analytics or real-time processing of big data. So that is a recent phenomenon that is gaining a lot of interest among IT professionals these days. There are several platforms that are coming up that helps to do real-time analytics on big data, because previously big data processing big data using real-time system is a difficult, is a challenging affair. Nowadays, with the availability of integrated and converged systems, it is getting easier to do real-time analytics on big data. So here, how VoltDB is facilitating that sort of analytics on a variety of data that are coming in is going to be discussed in the subsequent slides. So I don't want to talk much about VoltDB because that was explained in detail by John. And as far as our knowledge is concerned, it is a kind of in-memory and scale-out database. It is built to power the next generation of streaming data applications. And I heard and read that it is equally applicable for IoT data analytics also. So the modern architecture of this VoltDB provides fast data ingestion. That is a very important aspect for doing real-time analytics, and it provides massive scalability, real-time analytics, and a variety of tools, embedded tools and engines in order to enhance the data, in order to enrich the data that are getting passed through this platform. So another interesting thing is it is a kind of relational database management system so that we can leverage it for transactional applications also, apart from operational applications. So as per the slide, we have that it gives more orders of magnitude is better compared to conventional relational database management system. SQL is the standard query language for VoltDB, so that those who are comfortable with the SQL can use that SQL for doing processing, searching, or slicing, dicing with the database that is getting deployed in a VoltDB platform also. So it supports ACID transactions, and it provides high availability through database fault tolerance capability embedded inside. And for disaster recovery, they have incorporated this feature called database replication. The next slides give the overall reference architecture from end-to-end data ingestion to information visualization. That means data is getting ingested and it is being analyzed, and that knowledge that are extracted out of that analytics can be transmitted to any kind of information visualization tools. From there, a variety of maps, charts, graphs, other visualizations can be displayed for enabling non-technical people also to understand the knowledge generated. So the next slide is talking about how VoltDB eliminates the conventional RDBMS problems for real-time analytics. So typically, data and associated processing are partitioned together and distributed across the CPU cores. That is a kind of partitioning that fulfilling shared netting architecture. So the data is held in main memory, eliminating the need for buffer management, and the transactions are, as I told you in the previous slide, transactions can happen or can be accomplished through this VoltDB platform, and that we execute sequentially in memory. And it supports synchronous multi-master replication also, that is ultimately giving high availability. Okay, so two things. This VoltDB not only for fast data analytics or real-time analytics, but also it can do big data analytics through a seamless and spontaneous integration with Hadoop platforms. So that is a key differentiator of this VoltDB. And another thing I would like to tell here is we have done the similar experiment with the SAP HANA. SAP HANA is one of the competitors for this VoltDB platform, and we have found the performance and of VoltDB is good compared with SAP HANA. And another thing, SAP HANA typically supports centralized architecture, whereas VoltDB supports a kind of distributed architecture that leverages commodity hardware, so that the total cost of ownership when compared with SAP HANA is very, very less. So that is the point, that is the finding that we have come out with based on our experimentations. And we have done a small and simple demo also, and we have created some assets and published some white papers based on our experiment and experience gained out of that POC. We got, my colleague will explain about the hardware configuration and other things, how he did migrated this VoltDB to a SoftLayer cloud and how it got installed, how it configured there, and he explained about the application that he chose for doing the demo also. Other things, if there are any queries, we will respond at the end of the session. Now I will hand over the session to my colleague. He will talk about this demo, and we took a very simple application for the demo purpose, and we have, but however we have worked on couple of other applications also for VoltDB, and some more details about VoltDB, the convergence between VoltDB and SoftLayer cloud will be given at the end of the session. So, and now please wait for my colleague to start the demo.
Hi, my name is Kailab. Here I am going to show how the VoltDB is working on SoftLayer, how we are going to move into the SoftLayer cloud, and how it will be worked, and what is the performance, and how much fast is compared to some other our database to it will be worked. Basically I am working in a cloud and big data infrastructure software engineer in IBM for the past 7 years. Here I am going to discuss the deployment and configuration and uses of VoltDB on SoftLayer cloud. So before going to discuss about the VoltDB, what is the infrastructure we have to take to deploy the on VoltDB on SoftLayer cloud. So generally we logged into the SoftLayer cloud and we provision the what is the prerequisite of the VoltDB. Generally we was run over this VoltDB on SoftLayer more than 2 to 3 operating system. Like if you go into the CentOS, we tried, and Red Hat also we tried, Ubuntu, and such a kind of things we have tried on SoftLayer cloud. That operating system here we are basically was taken CentOS version 6.7 or later 6.7 we are taken here, this operating system. If you go into the CPU, we are taking a dual core processor and 64-bit and 1.6 gigahertz processor. The memory we was taken here to show the VoltDB we was taken is a 6 gigabytes of memory, and it's a Java. It can be suitable for 6, 7, and 8. It can be support for VoltDB. If you come into here, we are logged into the SoftLayer, and we provision the with respected operating system and prerequisites, and it will be give the IP address and username and password. We are logged into the SoftLayer, the CentOS with respect to username and password, on SoftLayer cloud. So if you come into the how it will be work with the VoltDB on SoftLayer cloud, we are migrated the VoltDB into the SoftLayer. We are downloaded the VoltDB into directly onto the Red Hat operating system. We are moved into the respected part of the software in SoftLayer cloud. If you move into the next slide in VoltDB installation, once you are moved the respected part of the VoltDB software, you have to deploy the VoltDB. Then you have to see the server completed initialization. So here we need to recognize that the VoltDB is successfully installed on SoftLayer cloud. Then if you move into the next slide, here we are going to take in a small application to run on VoltDB. Why we are taking the national bid best bid offer a bid. This is a very realistic day-to-day life. How it will be work? It is the best lowest availability ask price and the best higher availability bid price to investors. Then the buy and sell the securities. So the investors is a day-to-day life. They are going to sell and they are going to buy the shares on online. Though they need to get the information in time to see the what is the price of the share and how much can I sell is like that. That's why for that only we was taken the best bid offer application to here. This is what after the installation of the best bid ask application on VoltDB, we have to see the dashboard like this. Then if you move into the next slide, so how it will be going to run our SQL commands like queries, how much fast it can be shown into the on VoltDB. This is a very much it can be come into the in seconds. It will be show our result to come up the respected result. If you go into the dashboard of the VoltDB, you have to see the VoltDB Studio there. If you click on that, we are able to see the like VoltDB Web Studio. From that VoltDB Web Studio, you have to click on connect. You have to see here connect. Then if you click on connect, it will be going to connect to the respected server of the VoltDB where it's started. Okay. Then if you move into the next under the slide, how much once we have run the command like commands and everything, how much time it will be going to take a time to execute the command. If you see, it is we are taken very simple command, the select content from containers, and if you go into the next command, it will be taken is not even 1 minute. It is a completed in time is a 30 seconds of a time to show the result. If you move into the next slide, here is we was taken at a very big and is a complex SQL command to run. How much time it will be taken on VoltDB with respect to SoftLayer. So here we are able to see if you run into this big and very complicated query on the VoltDB, it will be taken not even 3 seconds to not even minute. It will be taken 30 seconds to execute this big and complex SQL queries. Yeah, this is from my end.
Okay, I'd like to thank you guys, Skylab, Peter. Appreciate the job you guys have done. That was great. So we have a few questions. If you're watching this live, it would be wonderful if you guys could help us out. We have a first question: is how helpful was this webinar? So this feedback, we use internally to help plan these things for our audience. Pick vary, somewhat, or not vary. That feedback is really helpful to us. So if you could go ahead and pick one of those, that would be great. And our next question is what other topics are you interested in learning about? So this also helps us decide what kind of content to create and what kind of webinars to run in the future. So if you have anything you'd really like to hear from VoltDB, we'd love to hear it. Okay, so we're going to answer a couple of questions now. If you have any questions, there's still time to get in and fill them out in the chat window in your webinar software here on On24. So we're looking through the questions here. So one of the questions is about ingestion rates that VoltDB can handle. And this is a good question. It depends greatly on the schema of the data you're importing, how many indexes you've got, but typically VoltDB is going to ingest faster than just about any system out there. So frequently in our workloads, we're working on how to get 10 gigabit Ethernet wire speed benchmarks running, depending on what kind of schema and what kind of parsing you're doing in your ingestion. It's pretty easy to get very, very high throughput in terms of hundreds of megabytes of data into an individual Volt server, and that can be grown as you add Volt servers. So very typically the ingestion rate with VoltDB is very, very high, and Volt is an excellent system for taking huge, huge streams of data and filtering it down, either through aggregation, through filtering, deduplication. You can take a really, really big stream and with Volt make it much, much smaller on your way to Hadoop or an analytics store. Next question. Okay, we got a question about typical VoltDB cluster sizes. They really vary quite a bit. Because of VoltDB's high throughput per machine, we tend to see clusters in the kind of double-digit sizes as large clusters. So we have in production, we have 60-node clusters. VoltDB, because of the millions of operations per second kind of system, we don't typically see 1,000-node clusters because they'd mostly be sitting idle. Very common are 3-node clusters set up for high availability so that nodes can fail. It's a huge upgrade over running a single database server or running a single traditional database server replicated to another server. VoltDB 3-node clusters offer increased performance over single-node replicated clusters and also offer increased fault tolerance and easier management because all nodes are active, all nodes are the same. So there's quite a few 3-node clusters out there. There's a large number of 10 to 20-node clusters out there, and there's a couple of larger clusters, up to about 60 nodes out there. We think Volt should run just fine up to about 100, and the future may run higher than that, but that's really our focus. Someone is asking for questions about real-time applications of VoltDB. So yeah, this is one thing where certainly you can go to our website and you can see we've got some information on some of the use cases and the verticals. One of the use cases we're working on polishing up right now is from Max CDN, which is one of the largest content delivery networks in the world. They're using VoltDB to collect metrics every time an asset is pulled from their CDN servers all over the world. They're using VoltDB to keep aggregates and proper counts transactionally so that they can get exact counts with exactly once processing semantics of those counters, and that enables them to get more accurate billing. So they don't have to underbill their clients. They can get precise billing for their clients. They can get precise understanding of what's going on in their cluster now. So that's sort of a metrics use case. We've got other customers who are building personalization systems. They're using VoltDB to understand and segment their customers in real time. When a customer comes to the website and starts behaving, VoltDB can look at that behavior in terms of what they're clicking on and what they're doing, and combine that with history, with the integrated state of what have they done before. Possibly even that that user may be known to the system and may be able to look up in VoltDB state what kind of user is. Do they have gold status? Are they in airline speak or hotel speak? Should they be treated differently? So it's enabled applications like we have an airline that uses this so that they can, if someone is using their airline application on a phone, the people who are manning the gate can say, well, we're missing one passenger from the flight. They can look and see, well, that passenger is using the app while they're moving through security in the airport, and that customer is a high-value customer. They're a loyal customer. So we're actually going to hold the plane for 5 minutes so we can get that high-value customer on the plane. However, it could say this person is using the app from an Uber, and they're 30 minutes from the plane, and that's going to say, no, we're not going to hold the flight for them. So Volt enables that kind of real-time decision, that kind of understanding, and really powerful apps for users in micro-personalization. If you go to our website, there's other use cases in finance, in telecommunications, in sensor networks, in online gaming, in ad tech, a whole lot of use cases to check out there. So this is a question. In terms of what kind of processing can you do in a VoltDB operation? So VoltDB, and forgive me if I'm getting this question wrong, but asking, in terms of VoltDB, the primary unit of stream processing is the stored procedure in VoltDB. And this is very similar to writing a bit of code that manages Spark streaming, microbatches, or it manages storm processing or Kinesis. It's a little bit of code that accepts your event off the wire and processes it. The difference in VoltDB is that event has access, that event processing code is a transaction and has access to the entire VoltDB state, either on the local machine or across the cluster. And so VoltDB, but the way VoltDB works, like many of these systems that offer exactly one semantics if configured properly, is that this has to be, there can be no side effects outside of the VoltDB state, the ingestion, and the export to a downstream system. So in terms of Volt, you have all the power of Java to do kind of whatever Java processing you want. You have all the power of SQL, all the power of VoltDB state, but in terms of additional functionality, calling out to the system, that should be done on the client side or at the event source side. It also can be done in the deep processing side, so we can move tuples into HDFS and then process them with Spark or with other tools like that. So one question about multi-data center support in VoltDB. Absolutely. So Volt has had multi-data center support for a number of years, and this year, in the fall, we've actually rolled out newer versions of our multi-data center support. We're getting much more mature in this area. So VoltDB supports active-passive multi-data center support that still supports strong consistency. We are also rolling out this fall active-active multi-data center support. So you can have local data centers for writes that can synchronize between them. And then that comes with all of the conflict detection that you need to make that kind of workload work. If you're interested in a multi-data center support, absolutely reach out to us. We can tell you a lot more about it and tell you what it works. All right, so we're going to wrap up. If there are more questions, we're going to try and answer those offline. We can get emails back to people, but I want to especially thank Peter and Skylab for the webinar today. The content was great. Thank you. And thanks for everybody who's joined us.
Thank you.
Thank you for your feedback. Yeah.